Claire. Today, let's talk about an easy problem. First, we actually would met some kind of problem. Is we have a quadratic function, and it looks like this. So that's mx squared plus x squared. So that's m plus 1 bracket times x squared. Okay, then plus 20x and then plus 25, and that's equal to 0. And ask you that m's range actually. We're going to find m's range, that is to find m plus 1's range, right? And m plus 1, right? Okay, let's think about it. So normally we're going to know that's very easy. And so we will use what? Of course, we will use the judge equation. That's about delta, right? Okay, now let's just write it. So first we know that the judge equation delta is equal to b squared minus 4ac. Okay, so we'll plug it in here. B is 20, so that's 200. Okay, and then minus, and that's 4 times a, so 4 times, so that is m plus 1, right? And then times c, that's 25. Okay, and what's the equal to? Of course, we know that should be, okay, let's just calculate it out first. So, of course, there's a condition. We say that this equation has a root, has roots. It didn't tell you how many roots does it have. So it means we can have 1 root or 2 root because it's a quadratic equation. So if we use the judge equation, that means the judge equation is gonna greater or equal to 0. Equal to 0, that means we have 1 root equal. Greater than 0, that means we have 2 roots. Okay. Now let's calculate 200. Then minus, so here's 4. And that's 100. Okay, 100 times m plus 1, and then that's minus 100m. Minus 100. And that's 100 minus 100m. Okay, we have this. Now this is supposed to be greater or equal to 0, right? And then we can calculate out the range of m. Here it's supposed to be 4. And here's 4, so here's 300, and so both sides divide 100, and we have 3 minus m. Right, we have 3 minus m, and okay, then we can move m there, then m less or equal to 3. Okay, this is it. So we have the range that m goes less than 3. So we actually have a question over here. For the question over here is that we can think about that we have a question because m plus 1. Okay, because this is what we're gonna find the range of it, and the domain of it. Okay. The domain of m, that is also we can say we're going to find a range of m plus 1, but the question is over here. Alright, we need to find a range. We didn't say, the question didn't tell you it must be a quadratic function, but it tells you that it just only tells you we had to let it equal to 0 and have root. Just x have some value. X have the value when we let this equation satisfy this situation. Okay, that means we actually can let m plus 1 equal to 0. Isn't that right? Because if it's like this, if it's in this case, then it is a linear equation. In this example, it turns to 20x plus 25. And that's going to be equal to 0. So linear equation, of course, we have roots. Okay, this is a question. Then we actually have to find out m plus 1 equals 0. That means m is equal to -1. Then it is in the domain that we calculate out. It's already included in m less or equal to 3. So here's the question. Find out. Okay then. So we're gonna find out that if this case always belongs, always is this case always is included in the range that we use the judge equation to find out. Okay, so here's the first step. Now let's see. So the ordinal form of a quadratic function, write as ax squared plus bx plus c. Alright, now I let this equal to 1. I'll calculate out, not calculate out. Okay. Like this is this file, like this have root, and find out the range of a. Just find out the range of n plus 1, then we can just have m anyway. Okay. Here's the point. We're going to find out the range of a, domain of a. Okay, let's write out a judge equation. That's delta equal b squared minus 4ac, and it's going to be greater or equal to 0. And then now we're going to think about some parts of the problem. Then let's think. In this case, c can be, first case, c greater than 0. Second case, c equals 0. Third case, and the last case is c less than 0. Okay, now let's see. First case, c greater than 1, then let's plug it in. We'll have to think that first step we have to move, because if we move it here, so we have 4ac. What's that? 4ac. Less or equal to b squared, and move 4c over here, so we have a less or equal to b squared over 4c. But we cannot write this step. You know why later? First, now we calculate it. Then we have that so first we know a is less or equal to b squared over c, but here's the problem. Now b squared over 4c, because c is greater than 0, that means c is positive, and b squared, whatever b is, that's always positive. Or actually can be equal to 0. Okay, we'll talk this later. First, let's just write out. So the first step, we have b squared over 4c. Actually, that's because b can equal to 0, and then the whole thing is equal to 0. Okay. And then that's greater or equal to 0. Great. And now, if we have this, then what about a? Now, a, I'm going to just write it again, right? A less or equal to positive value, b squared over 4c, right? And then the smallest value that this part can choose is 0. So our question is, does it include when a was 0? Of course, it does. Okay, now let's think of the second case. Okay, think about the second case. Second case, when c equal to 0, then we can't write it as this. Why? Because it's undefined. Because c is equal to 0, then 4c equals 0, then b squared over 4c, that's what? That is equal to 0. Right? And not that whole thing is equal to 0, because 4c is equal to 0, and that's the denominator. The denominator cannot be 0, or it's undefined. Alright, then it's undefined, then we can't write it as this. Then we look at the first here, over here. Oh, so that means, okay, and if we put it in, we only left b squared, and b squared, it satisfies greater or equal to 0. Alright, so what does that mean? That means a can choose any value that it wants. Okay, so a is a member of R, real number. A is a member of R, real number. Okay, now the last case, c equals, c less than 0. Okay, c less than 0. So first let's calculate out. Here's the different point. Okay, let's think. Oh, I'm going to calculate out that. All right, let's see. First, remember, 4c is negative, right? Because c is negative, because c is less than 0. So c is negative, then 4c is negative, and then b squared minus negative value times a. Okay, and then first we're going to move this part to here. Then we have 4c, it's 4ac. So we can actually write, we're supposed to write it as 4ca, and that's less or equal to b squared. All right then. But remember, now what do we do in the next step? 4c, both sides divide 4c, then here's a and here's b squared over 4c. But don't forget, 4c is negative. Then we should have changed the... we should have to change this. Now it is less or equal to 0. We should have to change this sign to greater or equal to 0. Then that is a greater or equal to b squared over 4c. Great. Now what's here? Okay. Then we have a greater or equal to b squared over 4c. Great. Now what's the next step? Now we have to break it to two parts because we are always thinking about b. Now in this case, we have to think about b again, but now it's different. Now let's think about b is not equal to 0 or b is equal to 0 because we don't have to think about when b is greater or less than 0 because b always squared, right? Okay, so what about b not equal to 0? That's very normal cases. You will know? Okay, so now right here, because c is negative, and so b squared, that is what? Okay, that is a positive value, and positive divide negative value. Okay, so you have a negative value. So it's b squared over 4c less than 0. Okay, that's a negative. Okay, then what about a? A greater or equal to b squared over 4c. Okay, then it's about to look. What about this? Of course, I forget to stay here. This includes a equals 0, right? What about here? Include a equals 0 because it's gonna greater than a negative value. Of course, it includes 0, right? Okay, what is that greater or equal to? Okay, so b was 0, then here b squared it is also 0. So 0 over the negative value 0. Then b squared over 4c equals 0. Now we have a it is less or equal to 0. Is that right? Yes, it is right. And that's greater than 0, so we can equal to 0. So it also includes equal to 0 in this case. Now we can say, oh yes. Sometimes they'll say, okay, now we have include. We have just check all the cases, then that include. All the cases is include when equals 0. Now I say, oh yes. So I don't have to break apart, say, oh, now a can equal 0, so okay, and it belongs to the domain that I calculate out, that I calculate, the answer that I calculate, okay, then I don't have to do this step, right? No, you must do this step because you can just plug in when a equals 0. And this part gone, and we only left bx plus c, so this is a linear equation. I just say when start from the problem, when we just not start from the problem, right when we write this. Okay, because it's a linear equation, so that's different. When a is not equal to 0, that is a quadratic situation, quadratic case. And when a is equal to 0, that is not a quadratic case, and it turns to a linear case. That is why we cannot do this. We cannot just only calculate delta. But you say delta is include. Yes. Then we have just to dig out when a equals 0. For if we only say we only allow this whole equation when it's a quadratic equation and then also have root. In this case, then we have to, because we calculate out and include a equals 0, then we have to, in that case, because we only allow the quadratic case, then we have to dig out when a equals 0, dig out, dig out, dig out. Right. So, now why does it exist? Because we didn't say we only let it's a quadratic function. We can also let it turn into a linear equation. But now, be careful, it is a linear case, so we have to talk about it specially. Now, in this case, it's a linear case, and that's bx plus c. Alright, but be careful. We cannot just let b equal 0, or that's become a constant term. There's no meaning. We don't have the x. Okay. So, in this case, no root. We can never let it equal 0. Okay. This is what actually we're going to talk about. So this is today's video. This is a very easy problem, but you have to be careful in this point.